The bevel-edged bench chisel. This is the chisel most people picture first. A flat steel blade, a sharpened cutting edge, and a wooden or plastic handle built to be pushed by hand or struck with a mallet. The sides of the blade are ground into narrow bevels, which let the chisel reach into tight corners where a thick, square-sided blade would get stuck. That makes it useful for cleaning joints, trimming wooden edges, removing small amounts of waste, and fitting hinges or hardware. The flat back is just as important as the bevel. When the back rests against a straight reference surface, the cutting edge follows it and produces a clean, controlled cut. The beginner mistake is using the chisel like a pry bar. Twisting the blade sideways can chip the edge, bend the tool, or split the handle. A bench chisel is versatile, but it is designed to cut forward, not lever sideways. The Mortise chisel. This one looks like an oversized bench chisel, but the blade is much thicker from front to back and usually has strong, square sides. That extra steel exists because mortising is rough work. The chisel is driven deep into the wood, the waste is broken apart, and the blade is sometimes levered slightly to lift the chips from the hole. A thin bench chisel can flex or snap under that kind of force, while a mortise chisel is built to survive it. The width of the blade normally matches the width of the mortise, allowing the sides of the tool to guide the cut and keep the wall straight. The trade-off is precision. Its thick blade and steep cutting angle make it poor for delicate trimming or shallow paring cuts. It removes waste aggressively, but it is not the tool you reach for when the final surface must be perfectly smooth. The paring chisel. A paring chisel is long, thin, and designed for control rather than impact. The extended blade gives your hands more leverage, allowing you to make extremely fine cuts using body pressure alone. It is ideal for shaving the wall of a joint, fitting a tenon, cleaning the bottom of a recess, or removing a paper-thin layer of wood without damaging the surrounding surface. The blade is usually ground at a lower angle than a heavy-duty chisel, which helps it slice cleanly through the fibers. That sharp, delicate geometry is its weakness. A paring chisel should normally not be struck with a hammer or mallet. One heavy blow can damage the edge, bend the thin blade, or split the handle. The proper technique is to keep the flat back against the reference surface and push slowly, letting the sharp edge remove tiny, controlled shavings. The carving gouge. Unlike a flat chisel, a carving gouge has a curved cutting edge and a blade shaped like part of a hollow tube. That curve lets it create hollows, rounded channels, flowing contours, and decorative shapes that a straight blade cannot produce. Gouges are classified by width and sweep. The width tells you how broad the cutting edge is, while the sweep describes how shallow or deeply curved the blade is. A low sweep produces a gentle curve, while a higher sweep creates a much tighter hollow. The important detail is grain direction. Push a gouge in the wrong direction and the blade can dive beneath the fibers, tearing out a large chunk instead of making a clean shaving. Carvers often change their cutting direction as the grain changes across the workpiece. A gouge is not simply a curved chisel. Its exact curve determines the shape it leaves behind. The cold chisel. Despite the name, this is not a chisel that must be kept cold. The word cold means it is designed to cut metal without first heating the metal in a forge. A cold chisel is made from hardened steel with a thick body, a wedge-shaped cutting edge, and no separate wooden handle. It is struck directly with a hammer to cut bolts, split rivets, remove seized nuts, shear thin metal, or chip away unwanted steel. The cutting edge is usually ground at much steeper angle than a woodworking chisel because it must survive repeated impacts against metal. Over time, the struck end can expand outward and form a mushroomed rim. That rim is dangerous because small pieces of hardened steel can break away when the chisel is hit. Grinding the mushroomed end back to its original shape is part of normal maintenance, not an optional cosmetic repair. The cape chisel. This is a specialized metalworking chisel with a narrow cutting edge and sides relieved behind it. That shape allows the tool to cut deep, narrow grooves without the wider body rubbing against the walls and being trapped. It's commonly used for cutting keyways, cleaning narrow slots, forming oil grooves, and removing metal from places a standard cold chisel cannot enter. The cutting edge is wider than the relieved section behind it, creating clearance as the chisel moves deeper into the workpiece. The mistake is treating it like a general-purpose chisel. Its narrow edge concentrates the entire hammer force into a small area, so it can dig in quickly or wander sideways if the first groove is not started carefully. A cape chisel is excellent at producing narrow channels, but the accuracy of the finished groove depends heavily on the angle of every hammer blow. The masonry chisel. This is built for brick, concrete, block, or masonry rather than wood or metal. The blade is thick, the cutting edge is blunt compared to woodworking chisels, and some versions use a carbide tip to resist wear against abrasive materials. Instead of slicing clean fibers, it concentrates impact into a narrow line and fractures the material ahead of the edge. It can remove mortar, break concrete, shape stone, open small channels, or clean rough masonry edges. The tool should normally be struck with a club hammer or drilling hammer, not a lightweight carpenter's hammer. Masonry produces unpredictable chips, so eye protection matters more here than with almost any other chisel. The tool also needs to be held at the correct angle. Too flat, and it may simply skid across the surface. Too steep, and it can bury itself without breaking away the intended material. The brick bolster. This is the broadest chisel on this list, with a wide, flat cutting edge designed to spread impact across a wide section of brick, block, or masonry. It's commonly used to split bricks, remove large sections of mortar, cut channels, or clean straight masonry edges. To split a brick accurately, the cutting line is usually marked first, then lightly scored across several faces before a stronger blow completes the break. Trying to split the brick with one uncontrolled strike can send the fracture in the wrong direction. The wide blade also makes the bolster useful for removing tiles or breaking away broad, thin sections of material. But width comes with a trade-off. It cannot reach narrow joints or detailed corners as effectively as a smaller masonry chisel. A bolster is built to move a lot of brittle material across a wide line, not perform fine shaping. One sharpening detail matters across almost every chisel. The edge angle must match the work. A low, thin bevel cuts easily, but damages more quickly. A steep bevel requires more force, but survives heavier impacts. Woodworking chisels need a polished, razor-sharp edge because they slice fibers. Metal and masonry chisels need tougher, more durable edges because they survive repeated hammer blows. Sharpening every chisel to the same angle may look consistent, but it ignores what each tool is built to do. So, the bevel-edged bench chisel handles general woodworking. The mortise chisel survives deep, heavy joint cutting. The paring chisel makes delicate, hand-powered corrections. The carving gouge creates curves and hollows. The cold chisel cuts ordinary metal. The cape chisel forms narrow grooves and keyways. The masonry chisel breaks concrete and stone, and the brick bolster spreads force across wide masonry cuts. The right chisel does more than match the material. Its blade thickness, edge angle, width, and shape decide how the force enters the workpiece and whether the material cuts cleanly, breaks accurately, or fails in the wrong direction. If you enjoyed the video and want to support this channel, click the subscribe button so you do not miss any of my future uploads.